Picking back up where we left off, we can talk about the mean and standard deviation formulas. The mean and standard deviation of a Poisson random variable can be given by the following two formulas. We have the mean is equal to lambda times t, which is what we did in the last example. Lambda would have been 2 cars per minute, and t would have been the 5-minute interval, so that gave us 10 cars. So that would be the mean for that. And then if we wanted to get the standard deviation, we could simply take the square root of that, and that would give us the standard deviation. And so then there's also the probability distribution function that we can use, and it is given by the following. And so if x is the number of successes in an interval of fixed length, and x follows the Poisson process with mean mu, the probability distribution for function x is the following. So the last thing we have here is this slide, and we're going to work this out right now. So let's go ahead and look at that. So we've got this question. It says a biologist performs an experiment in which 2,000 Asian beetles are allowed to roam in an enclosed area of 1,000 square feet. Area is divided into 200 subsections, each of 5 feet. If the beetles are spread evenly in each enclosed area, how many beetles would you expect per subsection? So if we have A, we have 2,000 beetles divided by 200 sections, which is going to give us 10 beetles. Hope I spelled that right. Yeah, per section. Okay, part B said, what would the standard deviation of x be if the number of beetles in each particular section, in each particular subsection? So we know here that this is mu 10, right? Because we had, what did we have? We had so we basically took the average of how many should be in each section, and so that would be your mean, your average, duh. And so we have our mu x is 10, and so we know if we want standard deviation, then we have the square root of 10, which I believe is 3.2 maybe? Yeah, I guess it's around 3.2-ish. So our standard deviation is 3.2 beetles. What's the probability of finding exactly 8 beetles? So this is going to be a Poisson PDF. And we know that each one has approximately 10 beetles. And we want to know 8 in each section. So if we do that, we have second vars Poisson PDF 10, 8. That gives us 0.1126. So there's about an 11% chance that this happens. And then if we do part D, would it be unusual to find more than 16 beetles per particular section? So let's look at that. We have Poisson, and we want more than, so we want CDF 10, and we want more than 16, so that's going to be, we don't want to include 16, so we're going to have 16. Oh, and by the way, this is, sorry, I forgot, this is more than, so this is a, don't forget, this is going to do, sorry, this is going to require us to take a complement because this is always less than. So if we do this, we have 1 minus binom CDF Number of trials, that's going to be... Oh, I'm sorry, this isn't binom, my mistake. Sorry, I'm using the wrong one. It's Poisson. Here we go. 10, 16.02 70. Yeah. Okay, so in this case, this is less than 0.05, which is our usual check, less than 5%. So when that is the case, we typically say that that event is considered to be unusual, and therefore it would be unusual to find 17 or 18 or 19, or even more than that beetles per in any given section. And so we would say that that event is unlikely. I hope this makes sense to you. If you guys have questions, please don't forget to ask. I'm posting videos. You can find stuff in the help section, hopefully, my website. So hopefully you guys are taking advantage of those things. Thank you, guys.